Bridges are built from strong metals such as steel, and these materials are designed to carry enormous loads for decades. Yet, in rare cases, bridges can suddenly fail. One important reason is something called metal fatigue. At the atomic level, metals are held together by metallic bonds. In this type of bonding, positively charged metal atoms are arranged in a regular crystal lattice, surrounded by a sea of mobile electrons. This structure allows metals to conduct electricity and deform slightly without breaking, which is why steel is so useful for construction. However, when a metal structure experiences repeated stress, its internal structure slowly changes. Every time a vehicle crosses a bridge, the steel beams bend slightly. Temperature changes during the day also cause the metal to expand and contract. Although each individual stress is small, these stresses may repeat millions of times over many years. Inside the metal, these repeated stresses cause defects in the crystal lattice to move. These defects are known as dislocations. As dislocations accumulate eventually, tiny micro cracks begin to form, often near surface scratches, weld joints, or other areas where stress is concentrated. At first, these cracks are extremely small, sometimes only a few micrometers long. But with every new loading cycle, the crack grows slightly larger. Chemical processes can make this worse. For example, oxygen and moisture from the environment can react with fresh metal surfaces at the crack tip, leading to localized oxidation or corrosion. This weakens the material further and accelerates crack growth. Over time, the crack spreads deeper into the metal. The remaining intact material becomes smaller and smaller until it can no longer sew. To prevent such failures, engineers carefully study the fatigue behavior of metal alloys. Metal fatigue reminds us that even the strongest materials are not perfectly permanent. Under millions of cycles of stress and sometimes subtle chemical reactions, microscopic changes can slowly grow into large structural failures.
Chemistry, making life better.